The integrity of digital data is accomplished by hashing algorithms. What does this mean in practice? Assume that you just downloaded a file from the internet. How do you make sure that the source file was not altered while it was on its way from the source to the destination? In other words, you need a way to verify that the source file is authentic. You will hear a lot about one-way hash function, which takes an input like an email, for example, or a downloaded file, or a password, and generate a number out of it. Generally, the output is in hexadecimal, using some sort of an algorithm. Another popular concept that you need to know is this formula that you see. H is equal to capital H X. Let me simplify this notation for you. The lowercase h is what? It is simply the output. On the other side, the capital case H is the hashing algorithm. Example, MD5 or SHA-2. The small x near the capital H is the input data, like an email message or file or a password. In general, the purpose of hashing is to add a fingerprint to the piece of data exchange between a source and a destination. Now, here's the most important question. Where can I use hashing? Practically speaking, you can use hashing for generating a checksum for a file. By doing this, you can compare the generated checksum of the original file with the checksum that you generated after the download. I will show you a practical example later about this. Also, you can use hashing for storing passwords in the database. This technique will make sure not to store clear text passwords at rest. Hashing is also used in digital signatures. I'm not done yet. Even intrusion detection systems and antiviruses capture hashes of files and compare their values with signature definitions. This technique is used for capturing infected files. Before we finish this quick review of hashing, I would like to talk about the hash function requirements. Hashing should be applied to any variable block of input data. In other words, input can be anything and should not be limited. The hash output must be of fixed length, regardless of the input size. So, SHA-256 output length is always 256, nothing else. Now, for practical purposes, the output should be easy to compute. Also, the output results should not be reversible to its original state. That means if you have the small h, which is the output, then you should not be able to calculate the small x, which is the input. Finally, two different input values should not have the same output. And this is called collision resistant.